First, the star schema, and what Oracle calls the star transformation. So connect sh/sh. So this is a simple star schema. We've got our facts table with dimensions, 5 dimensions, going out by 1 level. Dimensions going out 1 level. Now, if I run a query against this, in some ways, it's going to turn out to be pretty inefficient. The query I'm going to run is this. I'll just have to configure my session a bit. My execution plans are going to get a bit more complicated here. And enable the auto trace facility again so we can see the execution plans. Now the query I'm going to run is this. Select sum amount sold from sales, natural join products, natural join customers, natural join times. Where product category is electronics, Cust City Oxford, day name Sunday. So beginning with prod category, well, the key to join to products is of course prod ID. And going to another schema, to sh, describe products. Each product is in a particular category, right? So I'm going to join to products and filter on category electronics. Cust City Oxford, we saw that earlier. Each customer is in a particular city. And as for times as well, the times dimension also seriously denormalized. For the times dimension, we've got a time ID, you've got the day name, number in week, and all this, totally denormalized information. But it makes the queries so much easier to write, and Oracle likes them. So this is a classic data warehouse query. I'm summing up the facts using filters on non-key columns of the dimensions. So how many electronics do we sell in Oxford on the weekends, on Sundays? Let's run it, and Oracle can do it. Oracle can run that query no problem. And we sold $1,200 worth of goods that met that criteria. But look what Oracle's had to do. This plan's quite complicated. Costs it $980. That's a minor point, which isn't relevant today, but it's done an index join at that point. It's managed to avoid hitting the products table and just joining a couple of indexes instead. But there it's hitting products to do a hash join to the result of times joined to customers and sales. So our join order, we are beginning with customers, doing a full scan of customers to pick out which customers in Oxford, and then we're joining to sales. No indexes. Then we're doing the join out to times, again, full scan of times. Partition join, that's a different matter. Join to that, and finally we join to products. Not much use of indexes there, and this is an exceptional case. Now I can assure you there are bitmap indexes on these dimension columns. Star transformation requires dimension tables keyed with B-tree indexes, and there will be B-tree indexes on these primary keys. The primary keys being, for example, time ID, prod ID, B-tree indexes there. But then you need bitmap indexes on the facts table. Right. And there's the usual debate over what your keys should be. I'm a surrogate key person myself. Now, how can we improve this and bring the bitmap indexes into use? We enable the star transformation capability. So there is a parameter which has to be set. By default, it is false. Show parameter star transformation enabled. Defaults to false. I'm going to set that to true, and then we'll see what these bitmap indexes can do in this particular example. Run exactly the same query as before.
John, is there any feature or addition required?
Enterprise Edition. Enterprise Edition to get the bitmap indexes and enable the star transformation. There is in fact a workaround we can do to get the equivalent of a star transformation in Standard Edition, which I will show you, as that will be relevant to many people. Assuming Enterprise Edition, we can do what I've just done here. And now we see a very different query execution plan. We are using these bitmap indexes. We're using bitmap indexes on sales times column. You'll have to trust me, that is the bitmap index on the sales time ID. That's the bitmap index on prod ID. That's the bitmap index on cost ID. So we're getting index access paths throughout. We haven't index access paths all the way. And you can see we're getting these merges as we merge the bitmaps together. That's the merge coming at that point. There's an AND operation coming in there. We're iterating, by the way, because the sales table is partitioned. So you have to iterate through the partitions in some cases. The cost has indeed come down. It's come down to 953. Well, is that statistically significant? And previously it was 980? Who knows? But the cost has dropped. But most importantly, we're getting good index access, whereas previously we were getting almost exclusively full scan operations.
I'm sorry, John, can you reinforce what did the cost change to?
The cost hasn't come down hugely. It's come down to 953 from 980, but you can't really say that means it'll be only about 5% faster. You know, one can't apply that sort of arithmetic to cost calculations. What one would look at, though, is the cost has come down, yes, and that's why Oracle chose to rewrite it into what they call the star transformation, because the cost was lower. But the benefits for your database and other users may well be huge. Instead of doing huge full table scans, that will probably involve checkpointing the table as you do direct read to PGA. You know, instead of hammering the disk with these full table scans, they're going to be getting far more efficient I/O by just scanning index access paths, going to these very small bitmap structures. So yes, the cost has come down, but these operations are going to be so much more efficient in many ways. With regard to the release, yes, you need star transformation to do that. There is in Standard Edition a very similar workaround. There are several ways of doing it. But what the star transformation actually is basically a query like this. Select some amount sold from sales. Well, previously, I said I did it as a join. A join. Well, without the star transformation, that's what we get. We're doing joins, hash joins driven by table scans. With the star transformation enabled, we get the bitmap access path. You don't see the word join there at all, do you? It's not being done as a join in the same way at all. This is an alternative if she's doing it manually. This is basically what the star transformation does. We rewrite the query to this form. Select some amount sold from sales, where cost ID in, select cost ID from customers, where cost city equals Oxford, and prod ID in, and so on. So rewriting the query like this is pretty much what this star transformation is doing. You take the section cost ID from customers where cost city equals Oxford. That's more or less what we're doing here. Here we're scanning customers to identify that cost city equals Oxford. And then, so we're doing that bit and using those rows, the keys it gets to then join back to sales. So yes, we're scanning the dimension, but we're avoiding the need to do that massive scan of the sales table, which might be terabytes big. So running the query like that, that's still doing the star transformation. Let me disable the star transformation. The Oracle is being a bit too clever for me there. I'll disable the star transformation and then see the effect of my manual code. Right. So having disabled star transformation, I'm now simulating Standard Edition. It hasn't really worked in this particular case. I'm playing games with the optimizer here, and I was hoping to get the same effect. Well, I didn't get it in that case. You win some, you lose some. And playing games with the optimizer doesn't always work.
John, just so you know, we had a question come in before about setting star transformation at the instance level. You were showing a session level. They said we could do it at database or instance level.
I've often wondered why that doesn't work by default. I've often wondered why it isn't enabled by default. I can't really see a downside to enabling star transformation. I suspect it's just backward compatibility. I can't think of any reason why they don't do it. Okay, now.
John, another suggestion perhaps, maybe hints would help your demonstration. I'm not sure you want to go down that path given the time constraint, but.
Let's see, yes, and it will also relate to the standard edition discussion. This is my query here, which is using, so I've disabled star transformation, and I'm running my query as joins. Right. A way one may be able to get around this in standard edition is indeed hinting another access path. But if I go to the Scott schema, in the Scott schema, we should see something that will perhaps be immediately relevant. I'll drop my bitmap indexes and create B-tree indexes. So this is the same demonstration I did before, B-tree indexes on job and depth, and then my query can join set autotrace on explain, picked an index, and then filtered to get rid of everyone who isn't a Clark. So index for one, filter for the other. Try it with a hint, the index combine hint, and we may see something a bit better. Temp, job I, depth I. And look at that. This should work with standard edition. I've had to hint it, however. I've had to hint it. So either Oracle thinks that this route will be slower, or maybe there's some statistics that need to be adjusted. But by hinting that, with my B-tree indexes, what Oracle has done is scan the bitmap index, dynamically scan the B-tree index, dynamically convert it to a bitmap. Scan that B-tree index, dynamically convert it to a bitmap, and then we see the bitmap hand coming in. How cool is that? So hinting can be quite important, but of course you need to work out why was the hint necessary. Well, standard edition, there could be a number of reasons. In this case, it's probably necessary because Oracle has worked out that it isn't actually the best way to run the query, but that's a different matter. You can, of course, with star transformation, as discussed a moment ago, you can enable it at the session level, the system level, or you can indeed hint it within one statement.